In 26A, part 1, we have to calculate the wavelength of the microwaves in figure 26.1. Well, wavelength is wave speed over frequency, and microwaves are electromagnetic radiation, so travel at the speed of light. The frequency we're given as 11 gigahertz, which is 11 times 10 to the 9 hertz, and this gives a wavelength of 0.027 meters. In part 2, we're to explain why the receiver in figure 26.2 now detects microwaves. Well, the gap is now similar to the wavelength, so the waves will diffract as they pass through the gap. In B, we're to compare the speed, frequency and wavelength of light in air and in water. Well, the speed reduces, the frequency is unchanged, and the wavelength reduces. In C, we have a semicircular glass block. We're to explain with the aid of a ray diagram how an experiment can be conducted to find the critical angle for light within the glass block and hence find the refractive index of the glass. Well, if we have a ray box here, so label that as a ray box. This is our semicircular glass block. We need to add a normal to the diagram. We'd then send the ray of light in like this, just make a colour that will stand out a little bit more. Okay, the ray of light would come in to the centre of the block, and what we want is the angle at which the ray comes along this face like this. This then is the critical angle, which would measure using a protractor. Then what we have is that the refractive index n is equal to 1 over the sine of the critical angle.